Okay, good morning. Good morning for today's class. Today I'll discuss especially for flow sheets, PID and PFD, and different valves, oil and gas, and water sand separation, how things are working altogether. I'll try to discuss in today's class. So already we discussed actually previous class PID and PFD difference. PID is actually detailed diagram. Whenever you are designing for surface production systems or gas gathering system, many times they say. So in that case, actually you are giving detailed diagram. Okay, detailed diagram, and PFD actually it will be approximated. Okay, more approximated so that you will understand the flow from where it is going one point to another point, how it is going, you can see this one. But PID will have more details like line number and valve number also will be there. Okay, so basically we in our course we will be focusing on PFD part, like how fluid is flowing from one point to another point and how separator designing and other design options will be there, we will discuss. And basically this whole course is taken from book Arlon. They have 4 volumes. So presently I am taking the content from volume 1, and some topic will be from other sources also. Maybe it is not discussed properly in that book. So in that case, I'll give the link or I'll give the source so that you can study from the original source of that material or course content. Okay. Whenever you are going for PFD or process flow diagram, so you have to remember certain notations or symbols so that you can quickly understand what is this one. For example, if you see valve, it is like dumbbell or cross. Okay, so this is valve, and check valve is like this, one way valve. Okay, you put one arrow. Okay, and relief valve is like this. Okay, in exam I can give like randomly, I can give valve and select or identify which valve what, so that one you should remember. Okay, air cooler, like it is like fan like sort of thing. Heat exchanger, like this is coil, electrical coil we are implying. Okay, and control valve means flow controlling valve. Okay, it will be like this, and one valve controlling mechanism. Okay, so fluid is entering here, fluid is going out here, and using this top portion, top semicircle thing, so that one you are turning and you are controlling the flow. And shutdown valve, it will be like this. Okay, in certain situation you have to shut down the system, so valve design is like this. Okay, you should remember these things, because whenever you are drawing any process flow diagram, you should put proper symbols. If you are putting wrong symbol, maybe I can cut marks in your exam. Okay, and for your objective type or 2 marks or 3 marks question, in that case also I'll try to check the accuracy, how much accuracy you are when you are drawing anything. So drawing also should be accurate enough. For example, if you are putting wrong valve, then I'll say okay, this is not proper, so you can get lower marks actually. Okay, so you should identify the symbols. There will be many other symbols also, but we can many symbols we do not use for our surface production systems, and many things maybe we'll be using, but these are the most common. Okay, and choke will be like this. Okay, choke is very common system for surface production operation. I think you already know. This is level controller. One circle will be there, then you put LC. Okay, level controller. Similarly, you see PC is pressure controller, TC temperature controller, TC. Okay, and if you have flow meter, then flow meter, like you make circle M or FQI. Okay, or sometimes put FM, that is also okay. Flow meter, and this is pressure vacuum valve like this. Okay, like this. And flame arrestor means flame should not be propagating, so they design like this, flame arrestor. And compressor picture actually in book is there something wrong, I corrected, I put here. So compressor, it like I have drawn like this. Okay, it is going like this and it is going out like this. Okay, it is like this. So, but in book it is given like this, so that may have done, they have done something error maybe. So this is wrong actually. Why? Because compression means you are compressing gas, means your volume is getting shrinked. Okay, so this is showing volume shrinkage. So any inlet is wider, is larger volume, and after that compressing is volume is getting lower. Okay, so that's why this symbol should be there. Whenever you are drawing compressor symbol, you should draw like this. Okay, so volume is getting shrinked, so that is the symbol. But if you are doing this one, I will put 0 marks. Fine, so it will be wrong. So compressor is like this. Okay, so if you are following book, that is fine, we have no problem, but if something error, then you have to note down this one. And fire tube again we will be using in our course. Fire tube symbol is like this. This is actually separator part. Okay, and it is cut out of separator. Like whenever you show any pipe, we show pipe like this. Okay, so we are showing this, we have cross section or cut from both end, and we draw like this. Okay, so you should note down this one will be going like this, another will be going like this. Okay, then it will look better. But if you are doing other way also fine, but normally this will be the notation for pipe cut. And here separator also, like pressure vessel. Separator is pressure vessel. I already told you, right? So separator is like this, and you are cutting like this, and one line here, and this is fire tube. Okay, so you are giving high temperature gas, and you are changing fluid viscosity of inside separator. Okay, so later we will discuss when we discuss about fire tube boiler and fire tube, how it is helping in separation. Okay, whenever you are increasing temperature, actually fluid viscosity will change. So when viscosity is changing, your separation rate can change. So that is the main purpose. And pump also integrated part of your system, actually surface production systems. Many places there will be low pressure and you have to transfer fluid from one point to another point. So in that case you use normally centrifugal pump, sometimes other type of pump also can be used. Centrifugal pump, normally it will be high volume flow rate pump. Okay, so later we will discuss further details. Centrifugal and positive displacement or reciprocating type pump will be there, basically used for your surface production systems operations. Centrifugal pump actually high volume, but pressure also it will be give you sufficient. But if you are requiring very high pressure, for example gas lift application, you need very high compression ratio, in that case centrifugal pump may not be working, centrifugal compressor or pump may not be working for very high compression systems. For example jet pump you are using, so you need very high pressure fluid you have to push into your wellbore, or gas lift system also very high pressure gas you have to inject into your wellbore. So in that case centrifugal pump may not be working properly. So in that case you use reciprocating type pump or compressor based on your fluid, like it may be liquid, it may be gas. Liquid means normally we say liquid gas pump, if we are having gas we say compressor. So machine is same, you are giving energy to fluid using some mechanical means. Okay, so the reciprocating pump or reciprocating compressor, basically principle mechanically same. Fluid mechanics, if you analyze fluid mechanics, you will have the basic fluid mechanics same equations, everything same. Only thing is that it is in pump it is incompressible, in compressor the term is compressor, so it should be compressible actually. But many places we do not differentiate. Okay, I mean it is cycle pumper we say. Roadside cycle vendors will be there, right? So whenever you have cycle leakage, tube leaking and air pressure gone down, so you have that reciprocating compressors, that is compressor, but you say pumper. Okay, although you are using different term, but purpose is a compressing actually, you are increasing pressure, right? When you are increasing pressure, your volume will be going down, so you are compressing. Okay, but actually technically we should not use those wrong terms. Whenever you are pumping liquid, so we will say pump. Whenever you are pumping gas, normally we say compressor. Fine. So pump, actually this figure is actually centrifugal pump. Later we will discuss when about the pumping systems. So, there you can see this actually centrifugal pump. Okay. For reciprocating pump, I think they did not use any symbol. This is common symbol used for your surface production operation pumping systems. When you are doing for PFD, you can put this symbol safely. Okay. So, we will assume this is pump, but if you are using this compressor one, this one, so we will assume, okay, the gas is there, you are compressing. Okay, but a gas line, if you are using pump, I will assume, okay, there is maybe some liquid. Okay, so you should not use wrong symbol. Okay. So, pump symbol is like this, centrifugal pump actually, or any type of pump also. Okay. So, if this symbol is there, I will assume this is liquid and you are pumping, you are giving energy to the fluid. But if you are using compressor symbol, you are giving energy to gas or natural gas or air, whatever, gaseous form. Okay. So, these symbols you should remember, and another is there, this is also compression system actually, this one also, but we will see whenever we will be using. But these are whatever I marked actually, check valve also here I have drawn, right. So, these are most common type of symbols used for PFD application, process flow diagram. Okay. A typical process flow sheet. So, now you got the symbols, now how to apply? Let us try to see. Let us say we have one vertical separator. Okay. Length is more than diameter and it is placed vertically. So, it is vertical separator. So, normally we can make like this. Okay. It is based on ground and one inlet flow will be there. It is coming from some wellhead or manifold, right. Some manifold will be there because different wellhead, wellbore will be there. So, like well 1, well 2, well 3, well 4, and different well will have different pressure, different oil and gas ratio also, GOR. So, directly you cannot put all fluid in single separator, because if you are putting single separator, different pressure is there. So, how to manage this one? So, you have to pass through manifold and you have to control the pressure, then you are putting into your vertical separator or horizontal separator. Okay. So, let us say first stage I am giving one vertical separator, this may not be true also, or just this is a hypothetical thing. Okay. And let us say you are separating gas. So, one mist extractor will be there, then gas is going there, you have one valve, this is valve, right, simple valve, we have, you can remember the symbol. Now, this should not be simple valve actually, it should be control valve. Okay. So, normally control valve will be drawn like this, pressure control valve, this make you wait PC, okay, pressure control valve. So, based on back pressure also you are checking your controlling pressure. Okay. So, I am putting pressure control valve there. Then I will have, okay, this is gas, right, this is water, because of density water will be bottom portion and oil will be here, and in between I can have some emulsion layer also, I can have some foam layer also. I am not showing all these things now. Okay. I am making simple drop diagram for PFD. Now, when you are getting water, you must have level controller. Okay. Level controller means LC. Okay. Then I will have one valve here. Okay. Okay. I am putting one level controller. Level controller I will explain later how it is controlling level. And so, if I am putting wrong valve, I will put 0 marks. Okay. So, you should remember what type of valve where I am putting. Then this fluid is going to maybe another separator. Okay. Maybe somewhere there will be pump. For example, let us say I am putting one pump. It may not be exact thing in actual scenario. Okay. So, that means I am handling liquid here, but in gas line if I put this symbol, same pump symbol, that means something wrong, gas is having liquid or I have done wrong drawing. Okay. So, this is typical process flow sheet. So, some more separator and descender and other thing you can put, but you're controlling the symbols whatever you learn, you should put all these things. If you are using, let's say, one horizontal separator with your heater treater, okay, right. Later we will discuss how it is working. So in this case you are using like increasing temperature, okay, and you are getting, let's say, water here. Water directly you are not getting, you must have control valve, right. So I will not put direct line, rather I will put one control valve, and only control valve will not work, I have to put some level controller, right, LC, then you put controller, okay. So whenever you are getting water, so water level must be maintained properly. If you are not maintaining, then water is too much down, then water pipe it will get oil only. If it is too high, then water will go into your oil line only, or completely filled with liquid, then gas outlet, this gas outlet will have problem, okay. So every case you have to use controller, so that you can control your pressure, your flow rate, you can maintain your pressure in certain sections, so you can use some pump, or certain section you can use compressor. There is many places there will be low pressure gases, so low pressure well bore is there, low pressure gas is there. So in that case maybe you have to increase pressure using some pumping mechanism or compressor mechanism, okay. Then you are putting into separator and separating, or you are making if you have different well bore with different pressure, and you cannot make separate system for all the well bores. First you have to make unification, you put in single separator, then handle everything together, okay. But if you say well 1 is having 1200 psi pressure, well 2 has 500, and well 2 will have separator system, well 1 will have separate system, it's not possible, it will be too much expensive. So you have to make only one system, and all well bore will be connected together via manifold. So that will be the best process, okay. So I will have one more flow sheets, I will show you different well bore. Let's say well bore 1 is having one valve, okay, and it will go to this choke to manifold, okay. Then this will have another valve, manifold. Well 2 also will have maybe same valve will be there, then choke, okay. Several valves, every place there will be several valves to control things, okay. You cannot keep anything uncontrolled. If there is any leakage somewhere, you must be cutting off that area, so you must have nearby valve. You because of one leakage, one problem, you cannot shut down whole thing. Maybe you will be stopping that small area and will be replacing that pipe or tubing, or you are rectifying the system, okay. So you will have many valve and flow systems. So these are manifold actually, production wellhead. And so this is a production manifold also. So all together you are saying production manifold. From there you are getting, let's say, one horizontal separator is here we have, then we will have this water line maybe, and water line must be controlled again, right. So maybe this is LC, then water line will go to your flotation chamber maybe, right, flotation chamber, this symbol for flotation chamber. So flotation chamber, from flotation chamber water will be disposed, gas will go to your gas line, that means this is low pressure system, so gas will be having very low pressure. So in that case maybe you have to use compressor again. So how to use compressor? You have to draw compressor system, right. You use compressor, then you put in main line, okay, and water whatever you are getting, so that you may have to pump to transport to another place. So you may have to put on pump symbol here, okay. So you draw properly. So okay, you may have to use pump symbol again. You have to put lever controller, pressure controller, temperature controllers in many places. Many places you have to use other type flow controller. Normally we do not control flow. Pressure controlling means it is controlling flow. but if you are using, then you have to use that. If you are using flow meter, then you have to put flow meter symbol, pressure gauge symbol. So all these symbols you have to use. Okay. So if I give you any flow sheet, you should identify what type of valve you are using where. Fine. Okay, pressure control. Whenever we are talking about pressure control, so pressure will be controlled using different types of valves actually. So sometimes you are narrowing down your piping systems. Let's say you have one pipe, you narrow down. So if you narrow down, your pressure profile will change. Okay. Many times you have to use separate valve arrangement. For example, your tap water is there at home or your hostel. Okay. So you are turning and you are controlling flow. And during coronavirus time, pedal operated valve also you have seen, right? Using your leg, you just press something and your flow will be controlled. And you have pressure cooker at home also, right? Pressure cooker in India normally use, but Western country they fear the pressure cooker is very dangerous. But in India normally we use, almost every household will have pressure cooker. So pressure cooker means it will have one vessel, right? So you can draw different way also. Okay, and there will be one hole here and there will be one valve. Okay, so valve will be pressure control actually. If pressure goes beyond 2 bar, so valve will be opening and it will release the steam. If you do not release the steam, what will happen? It can burst. If pressure will be very high, then it can be accident. Okay, there will be a safety valve also here somewhere. If you have see the lid of this pressure cooker vessel, there will be a safety valve. Safety, if that needle valve is not moving up and not releasing pressure, then safety valve will be working and that will release pressure and everything will be safe. Okay. So this valve will be operating if more than 2 bar pressure, it will be opening and noise will come and gas will be released, right. So this is safety valve and pressure control valve actually. Okay. So similar system you must have in your separator system also. If pressure is going beyond certain amount, then you must have a relief valve. Okay. And final one will be safety valve, means nothing is working, sorry. If nothing is working, the safety valve will be opening without anyone's control and it will make everything safe. Fine. So there will be different types of valves. So another thing is that tap, you have a household tap, right, or a hostel, everywhere you have seen that some tap will be there and you rotate the knob. So there what will happen, you have one pin, okay, and fluid will be flowing through this. If you turn it, so that small area, let's say fluid is flowing through this and you have pin and you are turning, so pin will close the path. If you unturn opposite direction, so pin will be move up, so fluid will be flowing continuously. If you tight like this, so pin will be closing this flow path. When closing flow path, fluid will not flow. This pin type. Okay. So close control possible. So sometimes you need very small amount of water, washing hand. Sometimes you need very dirty hand is there, so you want to open everything. So flow rate will be higher. So you can control flow also. You are stopping plus controlling, both you are doing. So many cases you are giving a close control. So one bottle you want to fill. So opening complete valve is not suggested. Small amount of opening is there, then you fill the bottle, other splashing will be there, you cannot feel actually, right. So different types of valves are there for different application. One is there shutdown valve. So if something goes wrong, whole system will be getting cut and system will be safe. Another is that pressure relief valve. So pressure is going up, it will be releasing pressure and it will make system safe. Okay. So the different types of valves are like one called gate valve. Gate valve. Okay. Gate valve means like you have one, I'll make, okay. Let's say this is my pipe. This is not good. I'll take another system. Okay. Let's say this is my pipe. Okay. And this is like gate. From top, you gradually you give linear motion, close it. So fluid is flowing through this. Now fluid will not flow. This is gate valve. Okay. It is giving only linear motion. just create a dam, you have seen, right? Gate will be there like this. Vertically you are moving down and up. Up means this flow is continuous, there is no stoppage of flow, and if you want to stop flow, move it down, done, closed. Okay, this is gate valve. The next is globe valve. Globe valve. So globe valve is like this. It will be like this. Okay, how it look like? Okay, so you see this is valve knob. Okay, open this top on this valve. Okay, so if you move up and down, so fluid is flowing through this. The arrow, you see the fluid flow direction. Okay, this is fluid flow. So fluid will be flowing like this, and if you move it up the valve, it will open the path, fluid will be flowing. If you move down again, it will be closing, right? So this one will be closing and opening. This, okay, move up and down, it will be closing. So this is called globe valve. Okay, so different orientation actually. You are restricting flow. Another is called a plug valve. Then butterfly valve. Butterfly valve is like this. I have one pipe, okay, and one valve is here. Just turn it. When I am turning it, you see this fluid can flow easily, and if I turn it like this, closed. Just 90-degree turn. Okay, if you give 90-degree turn, it will be flowing, closed. So butterfly valve. Okay, this is normally this will be using for bigger pipeline systems or bigger dam or somewhere. It will be very easy to control because 90-degree, just turn 90-degree, flow, stop, again turn 90-degree, again start, it will start flow. This is called butterfly valve. Okay, then needle valve. Okay, plug valve actually you have one stem like this, and rotate it, it will be closing path, again rotating up, it will be closing. So needle valve also similar function, but it will be controlling more precisely in needle valve. Okay, so needle valve we have one needle, and your flow path will be controlled more precisely. Okay, so this is called needle valve. Needle valve. Needle valve. Then I have pressure relief valve. You should remember the name of different types of valves and one or two line why it is using, how it is working. Okay, that will be okay, because you are not very much expert of valve only. So because if you are working on surface production systems operations or production as a production engineer, you should note the names of the valves. Okay, you should not say I don't know. Okay, you have different types of valve. Someone is saying, sir, I need one butterfly valve. So you should not see, okay, butterfly is flying like this, how it can be valve, right? So people are using the terms here. So you should remember, okay, gate valve, globe valve, plug valve, butterfly valve, needle valve, pressure valve, pinch valve, many other types of names are also there. But basically these valves are used for your surface production systems. Okay, so valve definition is that it regulates and control the flow. It regulates and control the flow and pressure. Control the flow and pressure. Okay.